This is notes for algebra, day 2 of unit 1, solving multi-step equations with variables on both sides. Ideas that we need to consider today are: first, simplify each side of the equation by distributing and combining like terms. You may or may not have to do both of these on every problem. Second, collect all your x terms on each side of the variable by adding or subtracting. Third, collect all constant terms on the other side by adding or subtracting. Fourth, solve for the variable by multiplying or dividing. This looks a lot like what we did in our first lesson. The difference is that we might have to combine like terms or distribute on both sides of the equation. On our first lesson, we just had to do it on one side. So in our first example, as I look on the left side, there's a 4x and a positive 3x. Those are like terms. Combine them together to get 7x. On the right side of the equation, we have to distribute. Negative 2 times 4 is negative 8x. Negative 2 times 5 is positive 10. So we've just done the first step. We've simplified by distributing and combining like terms. Second, we want to move all our x's to the same side of the equal sign. I'm going to move all my x's to the left-hand side. So this 8x needs to move. Since it's negative, I'll use the opposite of it and add 8x over, making sure I line it up with my other x term. So that gives me 15x minus 5 equals 10. We're done with the second step. Now we move on to third. Collect all constant terms on the other side of the equal sign. So this 5 needs to move to the right. Since it's negative, I'll add it over. And we get 15x equals 15. Finally, solve for the variable by multiplying or dividing. This 15 and the x are combined through multiplication. So to undo that, I will divide. We get an answer of x is 1. In our second example, we have 3/4 times 8x minus 4. Well, if we distribute 3/4 times 8x, that gives us 6x. 3/4 times negative 4 gives us negative 3 equals 5x minus 7 plus 2. Now, fractions are not always people's favorite items to work with. Our calculators now come with built-in fraction keys. So you'll see that we had the fraction 3/4. If I want to type that in my calculator, 3 fraction key 4 gives us the fraction 3/4. I can then multiply that to times 8. I'll use parentheses 8 equals, and I get 6. I can do that again. 3/4 times negative 4, 3 fraction key 4 parentheses negative 4 to show multiplication gives me negative 3. So we distributed. On the right hand side, we have two constants, negative 7 and 2. So now that gives us negative 6x minus 3. Negative 7 plus 2 is negative 5. So we've done step 1. Step 2, we need to put all of our x's on the same side of the equal sign. I'm going to move my x's to the left side. Since that x is positive 5, I have to subtract it. 6 minus 5 is 1x. Step 3, move all constant terms to the other side. Since this is negative 3, I will add it over. I have 1x equals negative 2. And we're done. In our third example, all we had to do was distribute. Negative 3 times 4 is negative 12. Negative 3 times negative 8 is positive 24. But you'll notice that in addition to distributing on the left, now we've created like terms. So my next portion of step 1 is to combine these two like terms together. 10 minus 12 is negative 2, plus 24 equals 2x. Again, I've decided to move all my x's to the left. Since that's a 2x, I'm going to subtract it over. Negative 2 minus 2 is negative 4. Over on the right-hand side, 2x minus 2x is 0. I have to include that 0 there. That's really important as a placeholder. So we've done step 1 and step 2. Now we're into step 3. Move all constant terms to the other side. 24 is my constant. It's positive. I'll move it to the other side through subtraction. Gives me the equation negative 4x equals 24. Final step, solve by multiplying or dividing. If I divide both sides by negative 4, I get an answer of x equals 6. Problem number 4, there's a distributing. Notice the item that's closest to the parentheses is a negative sign, so that means I'm distributing a negative, which is really the same thing as negative 1. So if I distribute the negative 1 to both sides, I get 4 minus 3x plus 5. On the right-hand side, I haven't done anything with it yet. But I notice that I've got lots of like terms. On the left side of the equal sign, I have two constants, 4 and 5, which gives me 9. On the right-hand side of the equal sign, I have a 2x and a 1x. If I combine those together the way I see them, since they're on the same side of the equal sign, 2 plus 1 is 3. So now we're done with step 1. Lots of distributing and combining in like terms. Then we have to move all of our x's to one side of the equal sign. I'm moving mine to the left. Take 3x, move it over through subtraction. Negative 3 minus 3 is negative 6x. Third step, move the constant to the right. That's a positive 9. I'll subtract it over. Negative 3 minus 9 is negative 12. Bring down the negative 6x. Last step is to divide to undo this negative 6 times x. So when I divide by both sides by negative 6, I get an answer of positive 2. Fifth problem. On the left-hand side, I have to distribute. 3 times 6 is 18. 3 times 4 is negative 12. On this side, I notice that I have like terms, 9x, 15x. They're on the same side of the equal sign, so I add them since that's what that sign says to do. 9 plus 15 is 24. Then I have to move all my x's to the same side. The 18x, to move it over to the left, I'm going to undo positive 18 by subtracting. So 24 minus 18 is 6. Third step, move all of our constants to the other side. So that means this 3 needs to move to the right. Since it's negative, I add it over. Negative 12 plus 3 is negative 9. Divide both sides by 6. If you're comfortable simplifying fractions in your head, you'll know that negative 9/6 is negative 3/2. Some of you will use your calculator and do negative 9 divided by 6, which gives me the decimal negative 1.5. You can also use your fraction key, negative 9 fraction key 6 equals, and this now becomes the mixed number negative 1.5, which is the same as this decimal negative 1.5. In example 6, I have to distribute the 2. So 2 times 4 is 8. 2 times negative 8 is negative 16. In the next step, I need to combine a bunch of like terms together. On the left side, I notice these two like terms. Combine them the way I see them. Negative 3 plus 8 is positive 5. On the right-hand side, we have 1x and 1x. Well, 1 plus 1 is 2. Then I have to take the x term and move it to the left. Since this is positive, I'm going to subtract it over. 5 minus 2 is 3. The 16, which is on the left side, I want to move to the right side. Since that's negative, I will add it over. 5 plus 16 is 21. Then I have to break up this 3 and x. That says 3 times x, so I'm going to divide by 3. 21 divided by 3 is 7. So these are your complicated solving equations with the variable on both sides. Now, sometimes we come across special solutions. Here's an equation where I've distributed the 2 to both sides. And then when I decide to move all my x's to the left, this 6 is negative. When I add it over, I have a negative 6 plus 6 that goes away. It cancels itself out. So I'm left with negative 18 on the left. On the right-hand side, I canceled this on purpose. I'm left with positive 18 on the right. Those are not the same. So what happened that was different? The x's canceled. They disappeared. And when your x's disappear, that gives you a special solution. Up till today, every equation we've ever done has had one solution. But there's actually two other scenarios. There's this scenario where you get something that doesn't make sense, negative 18 equals 18. There could be another scenario, as we're going to see down here. This equation, what happens when you simplify? If I distribute 2 to both sides, the left side is negative 3x plus 2 plus 9x, which is right here. Distribute, we get 6x plus 2. Combine my like terms on the left, negative 3 plus 9 is 6x. You'll notice both sides say the same thing. If I try to move my variable to the left side, because that's what I've been doing to remain consistent, 6x minus 6x, that's nothing. I'm left with 2 on the left. 6 minus 6 is nothing. I purposely canceled that out. I'm left with 2 on the right. 2 equals 2. So we've got two scenarios. Our x's go away and the two numbers are different. This is called no solution. Or we have the case where all the x's disappear and the two numbers are exactly the same. This is IMS, infinitely many solutions. Some students like to write all numbers. You could write that as well if you wish. So as we look at these next 4 examples, I've got most of it written out. We just have to decide what scenario we have. On question 7, the left-hand side, I see 2 like terms. Negative 4x plus 1x is negative 3x. On the right-hand side, we have a 7x and a negative 10x, which is a negative 3x. I'm going to move all my x's to the left. Since that's negative 3, I'll add it over. Negative 3 plus 3 is 0, so I'm left with 5. Negative 3 plus 3 is 0. I'm left with 2. All of my x's canceled. This is a special solution. I have the statement 2 equals 5. That's not true, so I need to write NS. Question 8. I need to distribute. 2 times 5 is 10. 2 times negative 4 is negative 8. I also have like terms on the left. 3x plus 7x is 10x. Now I'm going to move all my x's to the left. 10 minus 10 to make this 10 cancel. 10 minus 10 is nothing. I'm left with negative 8 on the right-hand side. Since I subtracted 10 on the right, I also have to move it over here. 10 minus 10 cancels. I'm left with negative 4. So we have the statement negative 4 equals negative 8. Not true. So we call that NS. Question number 9. 2 like terms, 19a, 5a. When I add them, that gives me 24a. Subtract 22. On the right-hand side, I have to distribute the negative 4. Negative 4 times 1 is negative 4, and negative 4 times 7 is negative 28. Bring down the 4a. Now notice that these two are like terms. I'm going to combine them the way I see them. Negative 28 plus 4 is negative 24a. Now you might think, oh, things are going to cancel because I have 24a's on both sides, but you got to be careful. This 24, when we were done combining like terms, is negative. To move it to the other side, I'm going to add it over. Notice here, this 24 is positive. Am I adding another positive 24? So that gives me 48a. Bring down the negative 22 equals negative 4. This is an equation like we were working with on the front-hand side. So we actually get an answer because we still have an a term left. So we have to continue the solving process. On the front, step 1 was to distribute and combine like terms. That's what we did in this section. Step 2 was to move all of our variables to one side. That's what I was doing here to move the 24a. Step 3, move all of our constants to the other side. So now I need to take this 22, move it to the right. Since that's negative, I'm going to add it over. Negative 4 plus 22 is 18. Now I have to get rid of the 48. I will divide. 18 divided by 48 is the fraction 3/8. Again, if you wanted to use your calculator to do that, you would type in 18 fraction key 48 equals, and that gives you the answer 3/8. Finally, question number 10. On the left-hand side, I've got two sets of like terms. I have x terms. Negative 17 minus 6 is negative 23x. I also have constants, 9 and negative 3. So 9 minus 3 is 6. On the right side of the equal sign, I have two like terms. The x's, negative 19 minus 4 is negative 23x. I also have the constants 15 and negative 9. Well, 15 minus 9 is 6. Take this 23. I need to move it to the left-hand side. Since it's negative, I'm going to add it over. Bring it over here. Negative 23 plus 23 is nothing. I'm left with 6. I made this 23x disappear, so I bring down the 6. I have the statement 6 equals 6. So this is an IMS situation, infinitely many solutions. The point here is that occasionally you'll have a special solution. 99% of the time in real life, we get problems that have an actual answer. Only sometimes will you have answers that are special solutions.